Welcome to AI Frontiers. Today's episode, Invisible Armor, AI, Computer Security, and Cryptography, highlights the latest discoveries in digital security, cryptography, and artificial intelligence. Drawing insights from 57 research papers published between July 5 and July 8, 2025, this episode explores emerging breakthroughs, transformative risks, and spotlights, a featured paper of the day. Stay informed to better protect your digital life. Over 57 new research papers on computer security and cryptography were published in just 4 days, exemplifying the relentless pace at which invisible defenses are advanced to protect digital data. These defenses operate much like the walls of a city, constantly tested, adapted, and repaired, often without the public's awareness. Most digital threats are intercepted before they become noticeable, highlighting the ongoing, largely unseen race among researchers to preserve online safety. The silent battles waged behind the scenes are essential for maintaining the security of our interconnected world. Every digital interaction, be it a photo upload, a financial transaction, or a message, relies fundamentally on trust established by computer security and cryptography. Computer security serves as the blueprint, alarm system, and guard for digital vaults, while cryptography provides the secret codes that lock these assets. As digital life becomes more pervasive, the need for robust, ever-evolving protections only increases. The research conducted in these fields directly shapes the future of privacy, safety, and reliability in the digital age. Consider the analogy of your data as treasures stored at a high-tech vault. Security encompasses the vault's alarm system, its guard, and the integrity of its design, while cryptography acts as the secret code that secures access to these treasures. Much like an immune system, computer security and cryptography must adapt continuously to new and evolving threats. As technology progresses, the range of potential vulnerabilities, the attack surface, expands, necessitating even more sophisticated defensive strategies. Securing artificial intelligence is a central focus in current research, as AI systems function both as protective shields and as potential targets. Researchers investigate vulnerabilities within AI, such as data poisoning, where attackers introduce harmful lessons during training, and jailbreaks, which involve prompts that manipulate models into violating their own safety protocols. These scenarios are akin to teaching an apprentice, where a single erroneous lesson can have significant consequences. For example, the work of Xiaomeng Hu and colleagues reveals the phenomenon of attention slipping in AI, where models inadvertently lose focus on critical safety cues. Protecting privacy in a data-driven world is achieved through advanced protocols that enable anonymous transactions and user control. Innovations in anonymization techniques ensure user data remains protected. Efficient unlearning methods have been developed to remove individual data points from trained models without requiring complete retraining, comparable to erasing a single brushstroke from a painting without disturbing the whole. Notably, leading privacy researchers have introduced efficient unlearning as a practical solution to these challenges. Cryptography research is intensifying in response to the looming threat posed by quantum computers, which have the potential to compromise current encryption methods. Fully homomorphic encryption, or FHE, enables computations on encrypted data, safeguarding privacy even during processing. The adoption of GPU-accelerated FHE, as demonstrated by Agulo Domingo and collaborators, marks a significant advance, making privacy-preserving computation feasible for real-world cloud applications. These developments are analogous to operating a secure safe without ever unlocking it, as security protocols are continuously refined to meet the demands of increasing computational power. Recent research reveals several key breakthroughs through a series of mini-stories. Xiaomeng Hu and team's identification of attention slipping provides a mechanistic explanation for AI jailbreaks. Agulo Domingo and colleagues' FIDEslib makes fully homomorphic encryption practical for cloud computing. Dao and others introduced backfed, bringing systematic order to federated learning security. The Q detection approach combines quantum and classical methods to detect poisoned data inputs. Additionally, new tools are being developed to uncover and address hidden vulnerabilities in hardware and compilers, underscoring the multifaceted nature of digital security. The featured paper of the day: Attention Slipping, A Mechanistic Understanding of Jailbreak Attacks and Defenses in Large Language Models by Xiaomeng Hu and collaborators investigates the fundamental reasons why large language models occasionally violate their own safety rules. This study focuses on jailbreak, prompts that bypass existing safety mechanisms, and finds that the model's attention tends to shift away from risky input over time. By unifying fragmented prior theories under the concept of attention slipping, the paper establishes a foundation for developing more targeted and effective AI safety defenses. Delving deeper into attention slipping, the research demonstrates that language models initially focus on dangerous input tokens, but gradually redirect their attention to less critical content as processing continues. This dynamic is likened to a chef who, despite starting with a strict instruction to avoid peanuts, forgets this directive by the end of the recipe. The phenomenon has been confirmed across multiple models in various attack types, providing an explanation for why many traditional defenses against adversarial prompts are sometimes ineffective. To counteract the issue of attention slipping, the paper proposes a defense mechanism called attention sharpening. This method involves adjusting the model's temperature parameter to maintain a precise focus on critical input elements, thereby preventing attention from drifting and efficiently blocking jailbreak attempts. Tested on 4 leading language models, this intervention demonstrates strong results with minimal performance loss, offering a practical, lightweight, and easily deployable solution. The approach sets a new benchmark for mechanistic research in AI safety. Looking forward, the field of security and cryptography can be envisioned as a flourishing forest, with each breakthrough representing a new root or branch. Mechanistic interpretability, as demonstrated in the study of attention slipping, enables proactive rather than merely reactive defenses. Quantum technologies are both nurturing new capabilities and posing fresh challenges. Privacy by design and secure hardware are emerging as standard practices. The movement toward open, rigorous evaluation is likened to a public garden, fostering progress through transparency and collaboration. In summary, security and cryptography are foundational to building trust in the digital era. Researchers such as Hu, Agulo Domingo, and Dao are at the forefront, driving progress measured by improvements in safety as well as performance. The evolution of these fields is shaped not just by technical innovation, but by active engagement from the wider community. By staying vigilant, informed, and involved, everyone contributes to shaping a safer digital future. The synthesis and review of this content leveraged advanced AI tools and human expertise. Research analysis was conducted using OpenAI GPT 4.1, with TTS narration provided by DeepGram, and visuals created via OpenAI image generation. Final content was reviewed by human experts to ensure clarity and accuracy, though some oversights may remain. All cited works are transparently referenced, and listeners are encouraged to consult the original sources for further details. Do not miss future deep dives. Subscribe now to AI Frontiers. This channel delivers the latest advancements in artificial intelligence, security, and cryptography research, serving as your source for staying ahead in technology. Join a vibrant community that shapes the future of innovation. Comment, share, and contribute to the ongoing conversation. In this podcast, the latest breakthroughs in computer science and AI are brought directly from the archive preprint server. From neural networks to quantum computing, complex research is simplified for your understanding. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.